Good afternoon, my name is Christine Robinson, and I'm going to be talking to you today about our team design project. The problem given to our team was to design a set of 4 instruments to the band Maroon and Gold Forest. They are a band that has a unique sound and is known for its use of unusual instruments. They're going on a new tour soon and are going to need as little space as possible to transport these instruments. If you look at slide 2, you can see the following requirements. The instruments have to fit in a 2-foot by 2-foot by 2-foot box. There needs to be 4 individual instruments. At least one has to be a string instrument, one has to be a percussion instrument, and one has to be a wind instrument. And it has to play one of 3 songs: the ASU fight song, the ASU alma mater, or the Ode to Joy. For my design, I'm going to be creating a pan flute to account for the wind instrument in the band. If you look at figure 1 on slide 3, you can see a basic sketch that I did of my design. The dimensions for my flute are going to be 3.02 inches by 0.5 inches by 9.85 inches. This compact size is going to allow for little room inside of our box. The physics behind my design is pretty simple. It uses the relationship between the speed of sound and the frequency of the note we're looking for to figure out what length of pipe we're going to need in order to create these notes. If you look at equation 1 on slide 3, you can see an example of one of the notes that I found. On slide 4, if you look at table 1, you'll see that using the equation from the previous slide, I've determined the proper length of pipe required to play the 7 different notes that would be used to play either Ode to Joy or the ASU alma mater. Finally, I determined an approximation of the cost of my project. If you look at table 2 on slide 4, you can see my budget. The pipe needed to create this flute will be about $4.97. The duct tape that I'm going to use to hold all 7 of the pipes together will be about $3.68. And the 2 craft sticks that I'm going to use as support for the flute are going to be about $2.94. All in all, it should cost me only about $12 to finish this project. I look forward to experimenting and learning how to build this flute and getting back to all of you when I have a final project. Next, Adam Kubiak is going to be discussing his instruments to the band in the box.
Hello, my name is Adam Kubiak, and for my portion of the Band in the Box presentation, I'm going to go over the instrument that I chose to make, which is a string instrument, and basically it's like a mini guitar. If you take a look at slide number 5, you'll be able to see my design. And what it has is a 6-inch by 6-inch base by 2 inches deep with a 6-inch by 2-inch neck extending 5 inches from the base. Now, what's cool about this design is that I'm going to make it with a removable neck so that when it's put away in the box on stage, it'll take up minimal space. A couple other design features of this guitar is obviously there is a circle centered on the strings to help with amplification of the sound. If you take a look at slide number 6, you'll be able to see all my tension, strength, as well as length and gauges of the string that I'm going to use. In addition, on slide 6, you'll be able to see my cost estimate. So the way I have it as it stands now is I'll be able to build this totally out of mahogany wood, which will help with the sound, as well as use real guitar strings and real tuning pegs for the top of the guitar for the tension. Now this is all preliminary, and as with any initial design, things are always subject to change. So I wish you guys luck on your design. Justin's up next, and thank you for listening.
Thanks, Adam. The next instrument I will introduce you to will be my xylophone design. This percussion instrument will be used to play 7 notes or frequencies, providing the low voice of the ASU alma mater song. Being built using pine wood and wire, this xylophone will be 15 centimeters long by 11.34 centimeters wide by 3.5 centimeters tall. Each bar will be 1 centimeter wide and 1 centimeter thick. There will also be a 1 centimeter gap between the bars to allow for the ease of playing and transfer between notes. 2 number 2 pencils will be used as striking tools to create musical tones from these bars. The formula used to determine the sizing of the xylophone is the frequency equals pi times the speed of sound times k divided by 8 times the length squared times m squared. K is equal to the thickness of the bar divided by 3.46. L will be the length of each bar, m equaling the mode. The speed of sound within Pinewood travels at 3,300 meters per second. So the number used for the speed of sound will be 3,300. Next, Jamie will introduce you to the instrument he will be playing and also provide you with our design justification.
Thank you, Justin. I am Jamie Curtis, a proud member of Fightin' Team 17, and I'm here with you today to explain and justify my idea for the project of Band in a Box. I chose palm pipes for my design primarily because they are simple, cheap, and reliable. A palm pipe is a closed-end wind instrument, and because of that, I use the equation of length equals the speed of sound in air divided by 4 times the length minus 0.61 times the radius of the pipe due to end effect. I will be using Schedule 80 PVC pipe as well as duct tape, and I will be using the duct tape to hold all of the pipes together. I will have 8 pipes in total to produce 8 notes, and the duct tape will not only hold the pipes together, but it will also isolate each tube from the next. Thank you for watching our project proposal video. Please view the PowerPoint slideshow if you would like to see our project justifications as well as each of our individual designs. Thank you.